Hello everyone, my name is Sethi. I hope you all are staying healthy. Today we are going to talk about analysis of variance, or you can say that ANOVA. ANOVA is just a way to settle argument between more than two groups. ANOVA is just a way to settle argument between more than two groups. If you want to compare averages of just two groups, for example, who drink more coffee, doctors or nurses, then you can use simple t test. But when you add one more group, for example student, then math become messy. That's why you need to use ANOVA. In short, ANOVA is a tool that handles three or more group at once. ANOVA does not look at a mean directly. Firstly, it look at a variance. That means it calculate F ratio. Formula of F ratio: variance between groups, variance within groups. Variance between group means gap between groups. For example, you want to test weight pills. Group A lost 2 kg, Group B lost 10 kg, Group C lost 20 kg. So here you can see so much gap between averages. So this is strong sign pills working differently. Variance within group means how individual inside each group, how individual within each group different from their own group averages. For example, within B group, everyone exactly lost between 9 to 11 kg. That means the group is very consistent because everyone within B group exactly lost between 9 to 11 kg. But if within B group some lost 0 kg but other lost 50 kg, that means group is very messy. It is very difficult to trust on averages of this group. Assumptions of ANOVA: independence, no cheating rule. That means each data point must be separate from another. Result of one person should not affect the result of other. For example, you are testing new method of teaching, but simultaneously you should not start testing students who are whispering answer to each other. You can test them separately if you want, but don't mix their influence while testing new method of teaching, because according to this assumption, result of one person should not affect result of other person. Next assumption: normality. Score should cluster around middle. Score should cluster around middle, forming a bell shape. That means normal distribution. Equal spread rule. Spread of data points should be roughly same for all groups. For example, score of A group are very close to each other, but score of B group is widely spread out. That means spread is unequal, but according to this assumption, spread of data points should be roughly the same for all groups. Next assumption: measuring tape rule. ANOVA is designed to compare mean of continuous numerical dependent variable like weight, height, time or test score. It cannot directly measure categories like favorite flavor of ice cream or eye color. There are two types of ANOVA. First is a one-way ANOVA. When you have one independent variable with three or more levels, it will be called one-way ANOVA. When you have one independent variable with three or more level, it will be called one-way ANOVA. For example, you are testing three different fertilizers like A, B and C, so that you can see how differently they affect on growth of specific plant. Here three different fertilizers A, B, C will be called three level of one independent variable. Here independent variable is fertilizer, and growth of specific plant is dependent variable, because growth of plant depend on a type of fertilizer. As we know, in ANOVA we use F ratio, variance between groups divided by variance within group. Mean of first group 6, mean of second group 8, mean of third group 11. Variance between group means how much mean of one group is different from mean of another group. That means how much group mean 6, 8, 11 are differ from each other. And variance within group means how much individual number inside each group is different from their own mean. That means how much 5, 7, 6 are different from this 6 mean. Similar, how much 8, 9 and 7 are different from this 8 mean. Similar, how much 12, 10 and 11 are different from its own mean 11. And most important thing, if between group variance is much larger as compared to within group variance, then you will receive high F statistic. And high F statistic suggest fertilizer actually matter for growth of a plant. Two-way ANOVA. You use a two-way ANOVA when you have two independent variables and you want to see if they interact with each other or not. You can use two-way ANOVA when you have two independent variables and you want to see if they interact with each other or not. For example, now you not only have two fertilizer A versus B, you also have watering frequency, daily watering frequency and weekly watering frequency. So here you have two independent variable. First is fertilizer, second is watering frequency, daily versus weekly, and one independent variable which is growth of a plant. As we know, we use F ratio. Variance between a group will be called signal. Signal is effect of treatment. For example, effect of fertilizer on growth of a plant. Variance within group also known as noise. Noise is just a random error. If value of F is larger, for example 10, that means signal is more stronger as compared to noise, and it suggests treatment like fertilizer actually did something for growth of a plant. But small f value, for example 1.1, means signal is not much stronger as compared to noise. So any difference you see on the growth of plant is just a random coincidence, not effect of fertilizer or daily watering. This is all about today's video. I think you got it, and thank you so much for watching this video. Bye, take care.